Hi everyone, welcome to our physics class. In the previous classes, we have studied about xt graph, vt graph, conversion of vt graph to at graph. What is the meaning of xt graph? Displacement time graph, a graph drawn by taking displacement along y-axis and time along x-axis. What is the meaning of vt graph? A graph drawn by taking velocity along y-axis, time along x-axis. At graph, a graph drawn by taking acceleration along y-axis and time along x-axis, right? So this is motion along a straight line. Part 7. Okay, well, let's start today's class. So today we are going to discuss about the next a very important topic, kinematic equations of motion. Kinematic equations of motion, derivation of first kinematic equation of motion, or derive or derive the expression of derive expression of equation of motion, derive the equation of motion, that is V is equal to V naught plus AT from VT graph. Okay, we have equation of motion. V is equal to V naught plus AT. Actually, so this is the first kinematic equation of motion. Okay, so what is this? This is the first kinematic equation of motion. V is equal to V naught plus AT. Okay, first let us consider the VT graph. What is the meaning of VT graph? A graph drawn by taking velocity, that is along y-axis, and time, that is along x-axis. So the velocity is measured in terms of meter per second. Time is measured in terms of second. Okay, so this is the origin. First, let us consider a particle starting with initial velocity v0 and moving with uniform positive acceleration. Consider a particle, starting with initial velocity, starting with initial velocity, that is v0, and moving with uniform positive acceleration. Okay, consider a particle starting with initial velocity v0 and moving with uniform positive acceleration. That means the velocity of a particle changes by equal amounts in equal intervals of time. Okay. is the initial velocity of particle. Let us consider this one as V naught. V naught is the initial velocity of particle. Okay. So here OA represents the initial velocity of particle. After that, the particle moving with uniform positive acceleration. Actually, at this point, the velocity of the particle is maximum. Okay. From O to this point. What is this? This is the final velocity. Okay. So this is V. V means the final velocity of the particle. V naught is the initial velocity. So V is the final velocity. Let us consider this point as P. The point A corresponding time is the initial time. So what is the initial time here? Initial time is equal to 0. And the point B corresponding time, that is actually the final time. Consider that one as T seconds. Okay. So the point A corresponding time is 0. The point B corresponding time is T. So actually here we have to find out the slope. The slope of VT graph gives which physical quantity? The slope of VT graph gives the acceleration. Is it not? Slope of VT graph. Slope of velocity time graph represents acceleration. Okay, first here let us consider this angle as theta. So what is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Okay, let's consider this point as C, this point as D. So here slope is actually tan theta. So tan theta is perpendicular divided by base. Is it not? Actually, sine theta, what is the mathematical expression for sine theta? Sine theta is perpendicular divided by hypotenuse. Cos theta is base divided by hypotenuse. Okay. Cos theta is base divided by hypotenuse. Tan theta is perpendicular divided by base. Okay. So I will give you a very simple technique to how to remember sine theta, cos theta, tan theta. Some people have curly brown hair, tightly pulled back. So actually this is a technique to remember sine theta, cos theta, tan theta mathematical expressions without any confusion. Okay, listen to me carefully. So this is a code. Some people have curly brown hair, tightly pulled back. Okay, so So P means perpendicular, H means hypotenuse, P means the base. What is the code? Some people have curly brown hair tightly pulled back. Okay, so tan theta is perpendicular divided by base. So in this right angle triangle, so this triangle theta, so BC is, what is this? Perpendicular. AB is hypotenuse. AC is the base. Okay, so slope of VT graph. Slope of VT graph represents what? Slope of VT graph represents acceleration. Represents acceleration. Okay, so slope is equal to A. Slope of VT graph represents acceleration. So slope is actually tan theta. Slope is equal to tan theta. So tan theta, that is equal to perpendicular divided by base. That means BC divided by AC, right? Slope of VT graph represents what? Acceleration. Slope gives acceleration. Acceleration is equal to BC divided by AC, because slope of VT graph represents acceleration. Okay. So what is the value of BC? So BC is actually final velocity minus initial velocity. Is it not? Actually, let us consider this point as E. So AE and BC both are same. So AE is equal to OE minus O OE minus OE. Is it not? That is the value of AE. So BC is equal to AE. So what is the value of BC? BC is exactly equal to V minus V naught. Okay. So value of BC is V minus V naught. So AE is actually equal to OE minus OE minus OA. So OE, this is the value of OE. OE is the final velocity. OA is the initial velocity. Okay. And AE, that is exactly equal to BC. What is the value of BC? BC is V minus V naught. Okay, BC is V minus V naught divided by AC. AC is equal to OD, right? So OD is the change in time, that is T minus 0, that is equal to T. Distance from O to D, what is this? This is actually T. OD is equal to T. This is T, or T minus 0, right? So OD is the change in time. So final time minus initial time is the change in time. So final time is T, initial time is 0, T minus 0, that is T. After that, we will get A is equal to V minus V naught divided by T. So AT is equal to V minus V naught. So V naught plus AT is equal to V. Finally, we will get V is equal to V naught plus AT. This is the fast kinematic equation. This is a fast kinematic equation. Fast kinematic equation is V is equal to V naught plus AT. So this derivation is very important for 3 mark. This is derivation of the fast kinematic equation of motion. Okay, that is from VT graph. What is the meaning of VT graph? A graph drawn by taking velocity that is along y-axis, time along x-axis. A graph drawn by taking velocity along y-axis, time along x-axis is called the VT graph. So here particle starting with initial velocity and moving with uniform positive acceleration. So that means the particle velocity changes. The particle velocity changes by equal amounts in equal intervals of time. So here V naught is the initial velocity of a particle. So V is the final velocity of a particle. Okay. So the initial time is 0. The final time is t. T minus 0 is the change in time. Okay. So V minus V naught. So that is actually the change in velocity. The ratio of change in velocity to the change in time. So that gives acceleration. Actually, the slope of this graph, okay, slope of VT graph represents acceleration, right? The slope is equal to tan theta. Tan theta is perpendicular divided by a. So what is the meaning of slope? Slope is the ratio of vertical distance divided by horizontal distance between 2 points on a straight line. Okay, so the next, a very important topic, derivation of the second kinematic equation of motion. Derivation of the second kinematic equation of motion, or what is VT graph. This is very important for 5 mark. Okay, so what is a VT graph? What is a VT graph? Derived the equation, derived equation of motion, equation of motion, that is x is equal to v naught t plus of a t square. This is from VT graph. This is very important for 5 mark. So again, let us consider first the VT graph. What is the meaning of VT graph? The graph drawn by taking velocity, graph drawn by taking velocity that is along y-axis and time that is along x-axis. Okay. Again here consider a particle. Consider a particle starting with, consider a particle starting with initial velocity v naught and moving with, consider the particle starting with initial velocity v naught and moving with uniform uniform positive acceleration. Okay, so consider the particle starting with initial velocity v naught. So this is the origin. Let us consider this point as A, this point as B. Okay, so the distance from O to A is this O to A. O to A is the initial velocity of the particle. Okay, so after that, let us consider this point as E. This point E. So O to E. Let's consider that is a final velocity, right? Point O to point E. What is this? This is the final velocity of particle, right? And then consider a vertical distance and horizontal distance between 2 points on a straight line. Let us consider this angle as theta. Okay, consider this point as C. So actually here BC is the vertical distance between the points A and B. AC is the horizontal distance between the points A and B. Just consider this point as D. Okay. So what is the value of AE? AE is OE minus OA. AE value is OE minus AE. So OE is V. AE OE minus OA. Right? OE minus OA. So OE is V. OA, that is V naught. Okay, OA is V naught. What is the meaning of V naught? V naught is the initial velocity of a particle. Actually, here particle starting with initial velocity V naught and moving with uniform positive acceleration. So what is the value of dc? So dc, that is exactly equal to E, right? So dc is also equal to V minus V naught. dc is V minus V naught. Okay, so this is equal to dc. Cause AE, that is equal to dc. So AE is OE minus OA. OE is the final velocity. OA represents the initial velocity. So the point A corresponding time is 0. The point B corresponding time that is considered, that is T. So OD represents the change in time. What is the value of OD? OD is equal to T. Right? OD is equal to T. So actually here we have to find out the displacement. how to find out displacement from VT graph? Actually, the area under VT graph represents the displacement. Is it not? So the area under VT graph, area under VT graph represents area under VT graph represents the displacement. Slope of VT graph gives acceleration. Area under VT graph represents the displacement. Okay, so here area of O, A, B, C, D. What is that? Trapezium. Okay, area of trapezium, that is equal to area of trapezium, that is O, A, B, C, D. Area of trapezium is equal to area of the right angle triangle ABC plus the of area of the rectangle is OACD. So area of right angle triangle plus area of rectangle gives the area of trapezium. Is it not? So area of trapezium, that is displacement. Is it not? Area of trapezium is x, because area under VT graph represents the displacement. Let us consider x be the displacement of the particle. Okay, area under VT graph represents displacement. Area of trapezium is equal to displacement of the particle. So area of right angle triangle. So area of triangle is O into base into height. So base is AC, height is BC. Okay, O into base into height plus area of the rectangle, that is length into breadth. The length is OA, breadth is OB. Okay, so x is equal to of into, so what is the value of AC? AC is equal to OD. OD is the change in time, t minus 0, that is t. Okay, AC value t into BC. What is the value of BC? That is V minus V naught. V minus V naught plus OA. OA is V naught into OD. OD is T. So after that, x is equal to V naught T. X is equal to V naught T plus of T into V minus V naught. But from first kinematic equation, V is equal to V naught plus AT. Okay, so what is the value of V minus V naught? V minus V naught, that is equal to AT. So x is equal to V naught T plus of T V minus V naught, that is AT. This is according to the first kinematic equation. So finally we will get x is equal to V naught T plus of A T into T square. Okay, so this is the mathematical expression for second kinematic equation. X is equal to V naught T plus of A T square. The first kinematic equation is V is equal to V naught plus AT. The second kinematic equation is X is equal to V naught T plus of A T square. Okay, thank you.